All right, so in our last section, we learned how to solve rational equations, and we're actually going to be talking about key features of rational functions. And some of this you may remember from just general key features, because we did briefly talk about what happens when I have a denominator. So we're going to be talking about a vertical asymptote, a horizontal asymptote. We're going to talk about x-intercepts. We're going to talk about y-intercepts. We're going to talk about holes of the graph. All of those things that we've talked about before, but now we're going to kind of pull it all together for a rational function. So when we talk about a rational function, the first thing that you're always going to do is you're going to factor. That is going to be the biggest thing when you do rational functions. And you're going to want to factor because those factors are going to help us determine, do I have a vertical asymptote? Do I have a hole? What do those pieces mean? So when I look at number 1, I see that I have x minus 3 in the numerator, and I have x squared minus 9 in the denominator. So if I factor that, that's going to be x minus 3 over, and this is going to be the difference of squares. So remember, the difference of squares says that I'm going to take the square root of both terms, and I'm going to get a plus or minus. So in doing that, I can see that I have two values in the denominator that are going to be undefined. But that does not mean that both of them are going to be a vertical asymptote. So when I'm looking at the denominator, anything that I remove from the denominator, anything I cancel, is a hole. Okay, so think about holes are removable. You're removing that value. So if I look at x minus 3 and I set that or say that can't equal 0, then I know that I have a hole at x equals positive 3. So what about the value that's left over? So what is left in the denominator is going to be my vertical asymptote, okay? So whatever you remove is a hole. Whatever is left in the denominator is going to be your vertical asymptote. So where is that vertical asymptote going to be located? Well, it's going to be located at x plus 3 can equal 0. So therefore, x can equal negative 3. Now, the only other thing that I kind of always like to point out with the hole is that the hole only gives you the x value. So I'm going to actually pull Desmos up and have this graph. Excuse me, guys. Let me get Desmos pulled up. I'm going to have this graph so we can see it. So I have y equals, and then in the numerator I have x minus 3. And then I have x squared minus 9. So I can clearly see that I have a vertical asymptote at x equals negative 3, which is where we said we would have one because that was the value left over in the denominator. But where do I have a hole located? So if I go to the x value of positive 3, so if I move my cursor and I look for the x value of positive 3, of course I'm trying to do this by dragging it, I can see that it's undefined. It's not going to tell me that y value. So how do I figure out the y value? Well, it's pretty simple. You take your x value and you plug it back into the original function that you had. Now, you're going to plug it into, or not the original function, excuse me, the factored function. So my factored function is now going to be 1 over x plus 3 after we remove the hole. So if I take and I plug in 3 here, okay, that's going to give me 1 over 6. So I'm saying that I have a hole at 3 and 1/6. And I can actually see that that is where that hole is actually located. I can see here, if I drag my point, let's see if I can get it to drag like it's supposed to. So if I drag my point to 3, I can see that it is located at 1/6. So if I see my open point there, there's the same value at that point. Now, you're not going to actually be asked to find the point very often, but if you are, you can simply find it by plugging in the whole x value into the factored form. So I'll say that again. You're going to plug the whole x value into the factored form. So when we factored this, we got 1 over x plus 3. We plugged in 3 and it gave us 1 over 6. So I had one vertical asymptote in that problem. Now, for the next problem, I have x squared minus 4, and I have x squared plus 4x minus 5. So we are going to factor this. So I should be able to see that I have a difference of squares again. And then on the bottom, I have the trinomial that I need to factor. So I need the multiples of 5 that are negative 5 that add to give me 4. So that's going to be 1 and 5, and that's going to be a negative 1. So this is going to be x minus 1, x plus 5. Now, in doing this, I'm not factoring anything here. I can't cancel anything out of this problem. So that means I do not have any holes. So I actually have 2 vertical asymptotes. I have a vertical asymptote at x minus 1, and I have a vertical asymptote at x plus 5. So I can graph this and actually see that happening here. So I have x minus 1 can't equal 0. So x can't equal 1. And then x minus 5 can't equal 0. So x can't equal negative 5. So I'm saying that I have 2 vertical asymptotes at positive 1 and negative 5. So if I do x squared minus 4, and then I have x squared plus 4x minus 5, I can see that I have a vertical asymptote at x equals negative 1. Sorry, that should be positive 1. And x equals negative 5. And that does occur there. I do not have any holes in this problem. And we will learn about a few more things as far as x-intercepts. So an x-intercept occurs with whatever's left in my numerator. So when I look at my numerator, I have x plus 2 and x minus 2. All right, so if I look at the values here, so I'm going to do this in orange so we can kind of color code here. So x plus 2 equals 0, so x equals negative 2. And I have, let me move this out of the way. All right, so now I have x minus 2 equals 0, so x equals positive 2. So if I look at my graph, I should be able to see on my graph that it crosses the x-axis, and it does cross the x-axis at negative 2, and it crosses at positive 2. So whatever's in the numerator is going to be your solutions, your x-intercepts, okay? Whatever is in the denominator is either going to be a hole or a vertical asymptote. If I can cancel it out, it's a hole. If it is left in the denominator, it's a vertical asymptote. And then the last thing would be the y-intercept. So the y-intercept is what you get when you divide your constants out. So if I take my y-intercept is going to be negative 4 divided by negative 5, which is going to be positive 4 over 5. Well, if I click over here, positive 4 over 5 equals 0.8. So these are all the key features that you can analyze just from looking at the equation. All right, so then I have x squared over x plus 2. I don't have anything to factor here. So what am I looking at as far as my values? Well, I have one piece left over in the denominator, which is x plus 2. That is going to be a vertical asymptote. That vertical asymptote is going to be x plus 2 can't equal 0. So therefore, there's a vertical asymptote at negative 2. Again, I can verify that. So y equals, and then I have x squared over x plus 2. And I can see that there is a vertical asymptote at x equals negative 2. All right, so then from there, I could also look, I could see that I am looking for my x-intercept. So my x-intercept is going to be what's in the numerator. Well, in the numerator, I have x squared equals 0. So if I take the square root, then x is still equal 0. Well, I can see that it crosses the x-intercept at 0. So that's your x-intercept. And then you're looking for your y-intercept. So your y-intercept are your constants. So technically I have nothing on the top, so we're going to call that 0. So 0 divided by 2 is still going to be 0. So my y-intercept is at 0, 0. which I can see that that's where it crosses the y-axis. All right, and for this last example, again, I can't factor it. So whatever's left in the denominator is going to be my vertical asymptote. There's no holes in this problem. So my vertical asymptote is going to be x squared plus 2 can equal 0. So I'm going to subtract 2, and x squared can equal negative 2. So if I take the square root of that, this becomes an imaginary number. So there is no vertical asymptote. There is none. You can't have an imaginary number for a vertical asymptote. And I should be able to see when I graph this that there is no vertical asymptote. So x squared plus 2. And I can see that there is no vertical asymptote because it is just a vertical line with a hump in the middle with a heel there. So the x-intercept, there is going to be no x-intercept because there's nothing in the numerator that I can set equal. There's no variable. All right, so the last thing would be the y-intercept. So the y-intercept, remember your y-intercept is going to be your constant. You're going to divide the constant, so 1 over 2. So your y-intercept here is going to be 0 and 1 over 2, which if you click, you can see that it is 0.5. All right, so just to kind of summarize here for a second, we have all of these pieces together. So the first thing we're going to do is factor your numerator and your denominator. You're going to cancel out any holes, and then you're going to look for your x-intercepts and your y-intercepts. Anything that's left over in the denominator is going to be a vertical asymptote. So what we need to do now is talk about the last thing, which is a horizontal asymptote. So the horizontal asymptote really is just a set of rules. So the set of rules says that if the degree of the numerator, so the degree is the largest exponent. So when I'm looking at this example right here, my degree for this example is going to be 3. That is the largest exponent, compared to the degree of the denominator. So the degree of the denominator is going to be a 1 because there's just an x. So for this particular example, 3 is greater than 1, so therefore there is no horizontal asymptote. If I were to graph this, I could see that. So I have negative 3x cubed plus x minus 1 over x minus 2. And you can see that there is no horizontal asymptote there. Now, if your degrees equal each other, so if your degree of your numerator, which is, for this example is 2, and your degree of your denominator is 2, then you take the leading coefficient. So the leading coefficients are the numbers in front of those degree values. So I have a 1, a 4, and a 1. So this time, my horizontal asymptote, y equals 4 over 1. So my horizontal asymptote is going to be y equals 4. Again, I can verify that. So y equals, and then I have 4x squared plus 1, and then I have x squared minus 7. And I can see that I have a horizontal asymptote at y equals 4. Now, make sure you draw close attention to the fact that vertical asymptotes are x equal, horizontal asymptotes are y equals. And then the last one, if the degree of the numerator, so for this one, the degree of the numerator is going to equal 1, is less than the degree of the denominator, so in this particular example, 1 is less than 2, then it is automatically going to be y equals 0. So if it's greater than, then there's no horizontal asymptote. If it's equal to, then you divide the leading coefficients, and then if it's less than, it's always y equals 0. Again, to verify, I have 2x plus 2, and then I have x squared minus 3. And then if I graph y equals 0, we're going to look at the outside pieces. So when you do horizontal asymptotes, it does not include that inside piece or that inside section. So the horizontal asymptote applies to the ends and the end behavior. Okay? So let's look at an example here. So we're going to do all of our pieces that we've talked about. So first thing I'm going to do is I'm going to factor. So I have the top part. So I need two numbers that multiply to give me negative 2, but add to give me negative 3. I think we're going to make that both negative. So I have x minus 1 times x minus 2 on the numerator. And then I need two numbers that multiply to give me positive 8 and negative 6. So that's going to be negative 2 and negative 4. All right. So in looking at this, I have 2 pieces in my numerator, and I have 2 pieces in my denominator. So I can see, all right, so I'm going to graph this, and we're going to talk about it as we look at the pieces. So I have y equals, and then I have x squared minus 3x plus 2. And in the denominator of x squared minus 6x plus 8. So for this particular example, we're looking at where do we have a hole, where do we have x-intercepts. So I have a hole, and I know I have a hole because I can cancel x minus 2. So that hole right there that we just canceled, x minus 2, okay, equals 0, or can't equal 0, so it can't equal positive 2. So if I go to positive 2 on my graph, I should see, let me go back just a little bit. There we go. It's undefined. So I have a hole at 2, or x equals 2. Now, what does that mean as far as the whole thing? So if I actually finish factoring this, this would be x minus 1 over x minus 4. All right. So the first thing I did here, and I'm going to label this so that we can see each step that we're taking here. So the first step is I factored. Then we found the hole. So the hole here, step 2. Now, I want to actually find the point. So remember, to find the actual point, I'm going to plug in my 2 value. So to finish finding my hole here, we're going to plug in 2 minus 1 over 2 minus 4. So 2 minus 1 is going to give me 1 over negative 2. So my hole is located at 2 and negative 1/2. And remember, I could just simply check that, 2 comma negative 1/2. And I can see that that's where that undefined piece was initially. Okay, so I found my hole. Now I'm going to state my x-intercepts. So my x-intercept is going to be what's left over in the numerator. So what's left over in the numerator right now is x minus 1. So x minus 1 can equal 0. And I'm going to actually go ahead and label this so that I know what I'm talking about for each one. So I know that I have a whole x-intercept at 1. Again, I can check my graph. My graph does show me that I have an x-intercept at 1. So I actually have a solution at 1. All right, so that was step number 3. All right, so step number 4 is the y-intercept. So remember, the y-intercept is we're going to divide our coefficients. Now, you can divide the coefficients of the factored form, or you can divide the coefficients of the original form. It doesn't matter. You'll get the same value. So for my y-intercept, I have 0, and I have 2 divided by 8. So 2 divided by 8 is going to be 1/4, which was what I would have gotten if I did negative 1 divided by negative 4, would have still given me 1/4. Again, I can check that, and I see that that's correct. So that was step 4. All right, so then step 5. Step 5 is going to be finding the vertical asymptote. Well, the vertical asymptote is what is left over in my denominator. So my vertical asymptote is going to be x minus 4 can equal 0. So x can equal positive 4. So if I check that, x equals 4, I can see that I do have a vertical asymptote at 4. And then step 6 is to find my horizontal asymptote. So step 6. So when we do this, it's going to be much easier to look at the original. So the degree of the numerator is 2, divided by the degree of the denominator is also 2. So my numerator equals my denominator, so therefore we're going to divide the leading coefficients. So the leading coefficients here are 1 and 1. So 1 divided by 1, my horizontal asymptote is y equals 1. If I graph that, I can see that happening at y equals 1. And then finally, you could sketch the curves if you graphed all that. I'm not going to make you graph it by hand. You have Desmos to verify all of this. I just want to make sure we understand where all these pieces are coming from. So, one more time. First thing you're going to do is factor. Second thing, you're going to identify any holes. And once you figure out the X value of the hole, factor it completely, cancel it out, and then plug that number back in to get your Y value of the point. Step 3 is your x-intercept. Whatever's left in the numerator is going to be where your graph is going to cross the x-axis. Number 4 is your y-intercept. The y-intercept is where you're going to divide the leading, not leading coefficients, your constants at the back of your problem were just the numbers. Vertical asymptotes, or whatever is left over in the denominator. And then your horizontal asymptote is the comparison of your numerator, the degree of your numerator, and the degree of your denominator. All right, so a couple more examples. So this one's just asking me to find the vertical asymptote. So I wanted to do an example that required a little bit more difficulty as far as factoring went. So the first thing I see for this one is I do see that I have the difference of squares here. So this is going to be 3x minus 5, and then I have 3x plus 5. Now, on the bottom, I see that I have 9, 78, and 105. So, like 105, I can't divide that by 9. And 78, obviously, that's not going to be divisible by 9 either. So when we're looking at these values, the only other thing that could even potentially be is 3. So let's look and see if 3 works for all of them. And 3 does. So we're going to GCF 3 out. So that leaves me 3x squared plus, for 78, that's going to be 26x plus 35. But even regardless of pulling that 3 out, I'm still going to have to factor this using my slide divide method. So I'm going to slide the 3 to the 35. That's going to give me x squared plus 26. And then that's going to be 35 times 3 is 105. I guess I should have realized that since I pulled 3 out of it just a second ago. All right, so we need two numbers. We need two numbers that are going to multiply to give us 105 and going to add to give me 26. So I just actually did that just a second ago. So for 105, we had 3. And that is, nope, that's not going to work. So we have 5 for that. Oh, 5, so we have 5 and 21. That'll work. So 5 and 21. So that's going to leave me with x plus 5, x plus 21. But don't forget that we slid the 3 over, so we do have to divide that back out when we're factoring, and then just simplify. So this is going to be, we're going to move that up, 3x plus 5, and then x plus 7. So this is divided by 3x plus 5 and x plus 7. Now, why was this necessary? Because if I hadn't have done this one, first of all, I wouldn't have been able to find the vertical asymptote. And I also wouldn't have been able to identify the fact that I have a hole here. So those holes, okay, those are not going to give me a vertical asymptote. So I have one vertical asymptote, and that one vertical asymptote is located at x plus 7 because that's what's left over in the denominator. So x can equal negative 7. So again, I can graph that whole thing. So if I put it in, I have 9x squared minus 25 over 9x squared plus 78x plus 105. And I can see that we're looking for negative 7 here. So y equals negative 7. And that should be an x. My apologies. And I have x equals negative 7 for my vertical asymptote. So there was only one this time. Now, for the horizontal asymptote, remember the horizontal asymptote, we're going to do a comparison of our numerator and our denominator. Well, how is that going to work if I don't have my problem already multiplied out? So you see down here, it's not multiplied out. Well, first thing, you can multiply it out if you want to, or you can just count how many x's you have total. So on the top, I have 1x. On the bottom, I have 2 x's. So how does 1 compare to 2? So 1 is less than. So remember we discussed that if it was less than, that means that it has a horizontal asymptote at y equals 0. So I'm going to finish this by graphing. And when I look at my piece here, I have on the top, I have x minus 8. And then I have 3 times x minus 9. And then x minus 8. And I can see that if I graph y equals 0, I have a horizontal asymptote that is correct for the comparison of those degrees. So you don't necessarily have to multiply it out. You just have to compare how many x's you have, which is going to tell you what is your highest degree. All right, and this last one, just kind of talking about everything to summarize, just to make sure we completely understand. So I'm going to factor in the top part up here. We're going to GCF this out. So we're going to GCF 5, and that's going to leave me with x minus 2. In the bottom, I need a multiples of negative 6 to add to give me 1. So 2 and 3, and we're going to make that 2 negative. So that's going to be x minus 2. And then x plus 3. Now, I have a hole here. Okay, so my hole in this problem is located at x minus 2 equals 0. So it's going to be located at positive 2. So after factoring that, I'm left with 5 over x plus 3. So remember, in order to find the y value of the hole, we're going to plug in 2. So I have 5 over 2 plus 3 equals 5 over 5, and it equals 1. So my hole is located at 2, 1. All right, so I'm going to verify that. So I have 5x minus 10, and then I have x squared plus x minus 6. And I can see that it is supposed to be located at 2. So if I graph here, if I go to 2, it's undefined. And I can see that it's at 2, 1, which is where that value was located when I clicked on it a second ago. All right, so the next thing we're going to look at, so remember our list, we found our holes. Now we're going to find our x-intercept, then our y-intercept. So my x-intercept is whatever's left over in the numerator. Well, I don't have an x value left over in the numerator. So I don't have an x-intercept. There's not one. You have to have some type of variable in the numerator in order for it to have an x-intercept. And actually, I can look at the graph and see that it's not going to cross the x-axis because there's actually a horizontal asymptote there. So then my y-intercept, remember that's going to be the division of my constants. You can use either one that you want to. So negative 10 divided by negative 6 or 5 divided by 3 of the simplified version. But my y-intercept is going to be located at the point 0 and 5 over 3. So I can check that, and I can see that I have 1.6 repeating, which is the same thing as 5 over 3. All right, so after we do our x and y-intercepts, then we have our vertical asymptote, and then we're going to do our horizontal asymptote. So the vertical asymptote is I have a vertical asymptote and I have one vertical asymptote. It is x plus 3 cannot equal 0. So x cannot equal negative 3. So if I plug that in, I can see that it does not equal negative 3. And then my horizontal asymptote is going to be the degrees of the numerator and the denominator. So the degree of my numerator is 1. And then the degree of my denominator is 2. So 1 is less than 2, so it's automatically going to be y equals 0. And again, I can test that, y equals 0, and I do have a horizontal asymptote there. All right, so all these pieces combined are going to give you those key features of your graph. The only extra thing that we are going to talk about is your end behavior. So your end behavior, so like for this particular problem, is going to be based off of your asymptotes here, or your holes, depending on how many you have or how many you don't have. So remember when we talk about end behavior, Okay, so as my x, on this side. So I'm going to just kind of clear out all of this stuff so we just see the graph. So my x value is going to go to negative infinity on the left. But as x goes to negative infinity, my y value is going to approach the horizontal asymptote of 0. Okay. So let me actually make this smaller, so I have enough room here. All right, so as x goes to negative infinity, y is going to go to 0. So now the right side, as x goes to positive infinity, my y value is also going to approach that horizontal asymptote, which is at 0. So same thing as the end behavior as it was before. It's just a matter